Hello friends, welcome back to another deep learning project, MNIST Data Classification. Here we will learn how to classify the MNIST data and what are the steps I have done to build the model and to create the model. Let's discuss on those topics. So at first I have imported the required libraries like Keras, NumPy, and from Keras I have imported layers. So let's run this cell. So it is taking some time to import libraries, so let's wait a while. I have imported the joblib library to save and serialize the model, and let's run this cell. So the second cell is successfully executed, and again I have imported warnings. These warnings is used to filter the unwanted and unnecessary warnings in the output. That's why I have used the filter warnings method of warnings library, and inside that I have provided ignore parameter to ignore out all the warnings. So let's run this cell. Okay, now the next step that I have done is I have loaded the dataset from the Keras dataset, and we are going to use MNIST dataset of the Keras datasets. So we know Keras is a very big gigantic library, and inside that datasets is a module which contains different types of datasets. So one of them is MNIST dataset. So keras.datasets.mnist.load data method, when we apply, it will load the MNIST dataset. So it results, or it loads into two tuples. One is for training, another is for testing, and inside those two tuples we can separate the two parts, or we can separate it into two parts: xtrain, ytrain in the training section, while xtest and ytest in the test section. So after loading the data to xtrain, ytrain, xtest and ytest, let's see the shape of xtrain and ytrain. So let's press shift and enter. So see guys, we have 60,000 rows of images of size 28 into 28, and in ytrain we have 60,000 levels. So let's see the shape of xtest and ytests. So again shift enter. So 10,000 images are available for testing, and 10,000 levels are available in ytest. So after loading the data, we need to scale the data so that every image data will be in a range between 0 and 1. That's why we are scaling the data. So it's an important step. So whenever you are going to apply or going to provide data to a neural network or any kind of deep learning model, we should remember to scale down the data. So I have done that same here. So let's run the cell. So if you want to see the first data point of extend, we can run extend of 0. So that's what I have done here. So let's run this. So see guys, this is the data points. These are the data points. So see, after we scale down these values, the values lies between 0 and 1. So after scaling the data, the next thing is to visualize the data. So when we visualize the data, we will understand much more better than what we saw in data. So for data visualization, I am using matplotlib, and in matplotlib another module pyplotlib is available, and that is alias-plt. So I am going to create 3 subplots. So if I equal to 0, we will get the second image. If I equal to 1, we will get the third image, and if I equal to 2, we will get the fourth image. So plt.show function will shows the plots. So let's execute this cell. So press shift and enter. So see guys, the first image is 0, the next image is 4, and the third image is 1. So after these things, I have created the model parameters, those parameters which are passed to the model. So number of classes is 10, because 0 1 2 3 4 5 6 7 8 9, these 10 digits we are going to classify, therefore the number of classes are 10. And input shape of the image is 28, 28, 1 is the image shape that we are going to pass to the model. So let's run this cell. Okay, it's done. Now we are going to expand the dimensions, because kernel will easily capture the important parts of the image. Thus to make the task easier, we are going to expand the dimension. So just we are adding another dimension for extend and xtest, and again we are saving or assigning the same to the same variable extend and xtest. So let's run this cell. Okay, it's done. Now let's check what is the new shape of extend and xtest. So here we have 60,000 rows, 28, 28, 1 is the new shape of extend, and similarly 10,000, 28, 28, 1 is the new shape of xtest. So after expanding the dimensions, we have to convert the y-train to binary format, because in y-train we have numerical numbers like 0 1 2 3 4 5 6 7 8 and 9. We want the values to converted into binary only. So we are converting using utils module, where we have two categorical method that will convert y-train and y-test into 10 classes. So 0 will be converted into all zeros, and 1 will be converted to 0 1, then 8 zeros. The 2 will be converted to 0 0 1, and remaining all are zeros. The 3 will be 0 0 0 1, and remaining all are zeros, like that all will be converted. So let's run this cell. So to see the zeroth of one y train, we are going to run this cell. Y train of 0 will give what after converting the class vectors to binary class matrices. So let's check it. So let's build the model. So we have come to model building part. So I have used the sequential class or method of the Keras library to create the model. So inside the sequential, I have passed a series of layers or a list of layers, so that one layer's output will be the input to the next layer. So at first I am getting Keras, or I have created input layer where the input shape is that what we have created during model parameters. This is the input shape 28, 28, 1. That is the input shape which will be passed to the input layer. Then a convolutional 2D layer with 32 units of neurons in the layer, and kernel size, the matrix kernel matrix size is 3, 3, and using the ReLU activation function in the layer. So its output will be passed to the max pooling layer, where the pool size is 2, 2, and it pulls out the max, it pulls out the important features from the image. Then again we are passing the pulled out features to the convolutional layer, which has 64 units of neurons and with the kernel size 3, 3, and again using the activation function ReLU, and its output will be given to another max pooling layer with pool size 2, 2. Then after pulling out all the features, we are flattening the pulled out data. Then using a dropout layer to have regularization in the model, and at last we are going with a dense layer which classifies the handwritten digits into the respective digit that we want. So here in dense layer we are providing the number of classes and activation function that we use in dense layer is softmax. So let's run this, and model.summary will give us the total whole steps that we follow to create the model, sequential model. So let's run this cell. So you are able to see that I hope you are able to understand. If not, I am going to explain this. The model is the sequential model, and we have this, the first column shows that we have 7 layers. The first one is convolutional 2D layer, then max pooling 2D layer, then convolutional 2D layer, then again max pooling 2D layer, then after flatten, dropout and dense layers. In the second column we get the output shape of the layers that we use. So 26, 26, 32. Similarly, each layer will give some outputs, and those output shapes are mentioned here. And in third column we have params, and how many params are passed to that layer. So after this table we have trainable params. So how many trainable params are available and how many non-trainable params are available, and what is the total params that we pass it to the model creation during model creation. So after building the model, we have to train the model with batch size equal to 128. That means we are using 128 data points at a time to train. So the next is epochs. So 15 epochs are used to completely train the model. 15 times we will train the model. So then model dot compile, it is used to compile the model. So what is the loss? Categorical cross entropy loss is used, and Adam optimizer, and accuracy is the matrix that is used to evaluate the model, and model dot fit will train the model. So in fit we are providing 5 parameters: xtrain and ytrain. These are the data that we provide to the model, and a batch size parameter to set the number of data points to use, and epochs, 15 epochs we are going to use. That 15 epochs the model will be trained, and validation split equal to 0.1. so 0.1% of data is used for validation. So let's execute this cell so that model can be trained. So shift enter. So see guys, model is trained. This is the first epoch. The accuracy is increasing and the loss is also decreasing. Second epoch is started. So in first epoch we have validation accuracy is 97% and validation loss is 7%. In second epoch we have validation accuracy is 98% and validation loss equal to 5%. See guys, the accuracy is increasing while loss is decreasing in each epoch. So in third epoch we have accuracy 97%, loss 8%, validation accuracy 98% and validation loss 4%. Similarly in fourth epoch we have 97% accuracy, 7% loss, and 98% validation accuracy and 4% validation loss. In fifth epoch we have 98% accuracy, 6% loss, 98% validation accuracy and 3% validation loss, and the accuracy increasing in each epoch and the loss is decreasing in each epoch. Similarly, validation accuracy is increasing in each epoch and validation loss is decreasing in each epoch, and it continues till the 15th epochs because we have used total number of epochs to be 15. So in the 8th epoch we have 98% accuracy and 4% loss, and in validation accuracy we have 99% and 3% of validation loss, and in 10th epoch we have 98% accuracy, 4% loss, 99% validation accuracy and 3% validation loss. The accuracy is continuously increasing and loss is continuously decreasing. Similarly, validation accuracy is also continuously increasing and validation loss is continuously decreasing in each epoch. The model is getting trained with these the 14th epoch is under progress. Let's wait a while, and the last epoch is started. In 14th epoch we have 98.92% accuracy and 3.29% loss and 99.18% validation accuracy and 3.32% validation loss. After all successful epochs, we have the accuracy 99% and loss of 3% and validation accuracy of 99.18%, while validation loss is 2.78%. So the model is successfully trained. Let's see the accuracy of the model and what is the loss with the model. Let's see that. So we have a method evaluate which gives us loss and accuracy of the model. So the evaluate method takes 3 parameters and two are compulsory, that is x test and y test, and I set the values equal to 0. So let's run this and check what is the loss and what is the accuracy of our model. So press shift and enter. So the test loss is 2.14%, while the text accuracy is 99.26%. So our model is performing much better. So we can use this model because 99% accuracy we have. So let's go for some predictions. So plt.imshow function will show the image x test of 737, and plt.show, the second line of code, is used to show the plot, and in ypred variable we have assigned the prediction of x test predicting by the model, and creating a list and assigning it to a variable L, ypred of index 737. So what is the, if the index value is the digit, so maximum of L and its index is the predicted digit by the model. So let's run it. So what is there in 737? Let's check. The image is looking like 6. So let's scroll down. What is the predicted digit? So see guys, the predicted digit is 6. Here it is shown, the predicted digit is 6. So our model is predicting correctly and accuracy is very high. So let's see the binary format of ytest 737. So let's press shift and enter. So 0 0 0 0 0 0 1 0 0 0. So 6 zeros, 1, 3 zeros. So in seventh place we have 1, that means it is 6. So after that we have to save the model so that we can use it in front end and in production. Similarly they also use, they save the model and use it somewhere else. Same thing we are going to do. So we are going to save it. So in a variable data to save, what are the needed things to save and use in our front end part, I am saving those things. So I need model and x test data points. So those two things are inside my dictionary data to save, and the data to save is saved using joblib.dump in model data.joblib file name. So with this, thank you guys. Part 1 is over. So let's start second part of the project, MNIST data classification. So in the second part we have to develop the front end so that users can easily use our machine learning model and they are able to classify the MNIST data. So let's start. So I have imported Streamlit, then JobLeaf, then DIL and NumPy. Streamlit is used to create the front-end widgets, while JobLeaf is used to load the shaped model. DIL is used as internals in JobLeaf and NumPy is for numerical calculations. So after importing the libraries, let's load the data that we saved. So the data is saved as model data.joblib. So using load method of joblib, let's load the data into the data variable. Then using the key model in data, we will get the model. Similarly, using the key xtest in the data, we get xtest data. So after getting the model and xtest data, let's create the page. So at first I am creating two columns without borders and the vertical alignment is center so that the items begin from the center. Then the gap between them is very small and two columns, one is with width 1 unit and the second one is 3 times the first one. So inside the column 1 I have created an image which is the logo that I use to show in all my pages, in all my projects. In second column, inside that I have written the title, that is MNIST Data Classification, with a beautiful number emoji. Then with an expander I have written about the project which shows what is that project and using what it is built. So I have written like this: MNIST Data Classification is a deep learning project that classifies the handwritten digits. And in second line, convolutional neural network is used to build the model. That is all about the project. So after that, using a warning status bar, I have created the model, and under that I have created a container which carries two columns. One is for input and the other one is for output. Both are of same width size and both are bordered, and the content under those columns are started from the top. So vertical alignment equal to top. So under column 1, that is for input, I have used an info status bar to show the input level and with an input icon. Then inside the input column, another two columns are created without different width sizes and without bordering them, and both of these columns start their content from the center of them. So the first column name is index call and the second column name is image call inside the column 1, that is the input column. So under the index call I have created a variable index where I am taking a text input that starts from 0 to 9999. So this image index is required, so that with this image index we can find out the image at X test with this index. That's why we are getting a text input from the users, so that we can find out the image in that index in test X test dataset. So under the image column, there is a if else block, where if index is selected, then index will be converted to integer 64 using numpy, and it is assigned again to the index variable. Then using that index we are finding the image in Xtest dataset and showing an image with st image with a width of 100 units. So if the index is entered by the user, if the index is not entered by the user, we are going with a default case, that is we are taking index at 0 and showing the image at index 0 in Xtest dataset. So then after getting the image at Xtest with the specified index, we are expanding the dimensions using numpy so as to get the correct features from the image. That's why we are expanding the dimensions. So expanded dimensions image in the variable input image. After that, in the output column, we are showing a status bar success, where label is output and icon is output icon, and using the model dot predict function, passing the input image, we are getting a prediction that is predicted by our deep learning model. As in the last layer we have used softmax activation function, it gives some values to all the outputs, so we need to find the maximum value. So maximum value at which neuron and at which index, that's why we need to find the index of that maximum value present at which node or neuron. That's what we have done, and we are showing that the digit is the index value. So that's all for output column. After that, I have created a like, then a media button, video button, repository button, connection button, and HF space. So all these buttons I created. So let's see how our project looks like. So to run this app.py file, press Ctrl Tilt so that our terminal opens up. Then change the directory. So what is the directory? cd. So it's MNIST_data_classification. So it's MNIST_data_classification. So the directory is changed. So to run a Python file, write streamlit run name of the file. So now press enter. So this is the app that we have created. So it's running. Let's wait for a while. It's building, configuring, and yeah, it came. So see guys, this is the 7 handwritten digit 7, and here showing the digit is 7. So already I said that the 0th index is the default index, that's why it is showing the digit is 7 and the image is also 7. And see, this is my logo. This MNIST data classification is the title, and this is the emoji I have used. And what is inside the expander, about the project expander, let's see. So it is written that MNIST data classification is a deep learning project that classifies the handwritten digits. Convolutional neural network is used to build the model. Okay, that's okay. So this is the input side, this is the output side. So let's change the index. So index should be entered from 0 to 9999. So let be the index is 15. So press enter. So the digit is 5. Let it be 78. Press enter. The digit is 9. Let it be 258. Press enter. The digit is 2. Let it be 5067. Press enter. The digit is 3. Let's change another value, 9911. Press enter. The digit is 0. So let's change again, 3629. Press enter. The digit is 8. So let's check another one or two values. 444. Hit enter. So the digit is 2. 5656. Press enter. The digit is 8. So guys, you know our model is showing accurate values